Thanks, man. That's why they pay me the big bucks. But anyways, I can teach you this real quick. It doesn't, like, everything that goes into this we have learned. We just haven't done it together. Here's the big difference. If you think of the graph as being like a window, these are inequalities, right? We've graphed one inequality at a time. If you graph one inequality, there was like a boundary. And then I remember I taught you there was like, oh, here's little son of Jair on the hill. And then, oh, is the mouth eating the Y? And then if the mouth was eating the Y, we shade the sky. If not, we shade the ground. Remember that part? So here's the only difference. When I only draw one boundary, how many sections does that break the graph into? How many? Two. There was two options. It was either sky or ground, and you would shade one. Whereas when there's two boundaries, how many sections does the graph broken up into? Yeah, it's 4. But you could still only shade one. So I find the best. The thing is, you have to look for the overlap. You have to look for the overlap. So I find that the best way to teach this is actually to take a step into another discipline. This one would be art. Go to the realm of art. Look, Georgiana, we're going to do art class now. We're going to take a little 3-minute break and do art. Do you like art? No? Primary colors. What are the 3 primary colors? Red, yellow, blue. Okay, I agree with that. I'm going to use blue and yellow. So if what I'm looking for is an overlap, and I'm using primary colors, specifically blue and yellow, if there is going to be an overlap anywhere in this paper, what color would magically show up even though I'm not using it? Green, because blue plus yellow equals green, right? Okay, so before I get into shading, let's make sure the boundaries are correct. Neither of these inequality signs have an or equal to, so they all have to be broken. All the boundaries have to be broken. So like really, I know that this cannot be this has a solid line, so it can't be B. This has a solid line, so it can't be B. So I'm down to either C or A. Then when it comes time to plot these, both of these inequalities are in slope-intercept. So that's why Emiliano knows that the slope of the first one is 6/1. The y-intercept is 0, -3. Then Jair's like, yeah, but look, the slope of the other one is 1/1, and the y-intercept is 0, 2. So if I look at this, it actually ends up being the same for A and C. They both have a boundary that's crossing at 2, going up 1, right 1, up 1, right 1, and they both have a boundary that's crossing at 0, -3, that's going up 6 and right 1. So the only difference between answer choice A and answer choice C is the shading. So let's see if we can figure this out on our own. Ignore the fact that part of this A is shaded. Let's pretend that there was no shading there on A. And I'm going to start with yellow. So let's shade this first inequality, the one with y less than or equal to 6 minus 3. So if I ignore the other boundary, I'm only going to look at this boundary here that was crossing at -3, where the slope is +6. And if little Jair was on that hill, it'd be a pretty steep one. He'd have a tough time staying on the hill. But if he were, since the mouth is not eating the y, would I shade the ground or would I shade the sky? If the mouth is not eating the y. The ground, yes, y littles go down, so it's like a little coloring book. I'm ignoring the other one, I'm only paying attention to this boundary here. Okay. But then little Colin decides that he wants to climb the other hill. So if I go look at the other boundary, the mouth is eating the y. So if mouth eats y, where do you shade? The sky. So I'm going to start shading this one blue. So it's like blue, 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 blue. Whoa, what is that? What just happened? I didn't even use a green marker. And look at that, some green showed up. So is there an overlap? Yeah, where's that overlap occurring? In that little skinny section on the top, which wasn't shaded on A, but it is shaded on C. Answer choice C. You writing that down, Nakai? I hate to see what your sad face looks like, and that's like a happy face. Fear the flutes? You guys have intimidating flutes?
Yeah.
So, there is a skull there, so that's scary. All right, so and we're here today until 12:34. I still got 30 minutes. Ooh, solve each system by substitution. Yeah, okay, so let's be clear on this. I highly doubt that there's gonna be an instrument available to you on the final exam that could force you to solve a system a certain way. Meaning, like, even though if this were to be a problem on the test, yeah, would you normally solve this using substitution? Probably not, right? Because what would be better off here? Why elimination? Both equations are in standard form, so I would use elimination. I had a student last week that asked me, "Oh, but if I do this with substitution, am I gonna get a different answer?" No, you're gonna get the same thing. So I'm gonna do it by substitution because that's what the directions say to do. But at the same time, I'm letting you know that on the test Wednesday for you guys, if all they're asking you is for is a solution and there's no way for them to check how you do it, then do it however you want. Now, if I'm gonna use substitution, I have to solve for a variable. What would be the best variable to probably solve for here? Variable, letter. Okay, but which x? I see two different x's. Which x? The top x, because that one has a 1 in front. So I'm going to go plus 3y and plus 3y. So I get that the top x is equal to 3y minus 3. So now I can go substitute and say negative 8, oh, not times x, times 3y minus 3 plus 5y is equal to negative 14. How has substitution helped me? What have I accomplished due to the fact that I substituted? Now there's only one variable, so I can solve.